So the first chemical change we're going to do here is magnesium. You can see that there is a formation of a new substance, and heat and light is also given off. So it's magnesium oxide. But just by observation, you're not necessarily going to know what chemical and physical reactions are, which I'll show later with the issues. This is thermal decomposition. So you add heat to the copper carbonate and black copper oxide comes off, and the carbon dioxide you might see bubble off. We actually collect that through calcium hydroxide that forms a precipitate. And so in that bubbling, the carbon dioxide that's bubbling off is actually another chemical reaction. The formation going through lime water, calcium hydroxide, forming calcium carbonate precipitate that makes it go milky. And so changing colour, gas is given off, typical or chemical changes, giving the idea there's a new substance. This one here, acid plus metal gives hydrogen, and then we're just doing the pop test. So the hydrogen comes off and you can light it and it'll make a pop noise. And this one here is a physical change. It's just melting, adding heat, and then it goes to a liquid stage. This one you have to feel for yourself. So I just put some sodium hydroxide pellets in water, and the students can feel it gets hotter. It's exothermic. And then sodium thiosulfate here, it actually gets colder, so you have to feel that one yourself. This one's just a visual one for the solid dissolving and going into spreading out through the liquid, and how to mix it. So you just tap it and it spins it around. Okay, so there's a lot of issues with this. So often when they say chemical changes, they're looking for heat and light and everything, but you can give many physical changes. This is electricity going through graphite, and there's heat and light coming off, and that is not a chemical change. So pretty much all the indicators of chemical change you can have for physical change as well. So not very useful. Also saying here that it's often reversible or irreversible. I don't think evaporating water is a simple process. There are so many reversible chemical reactions in equilibrium. All this one is you just add a little bit of heat and it moves to the left-hand side. Cool it down, it moves to the right-hand side. Very, very quick and easy to get. So many chemical reactions are easily reversible. Far easier to reverse than physical ones, to be honest. So the whole reversible thing doesn't work. I think that's just a lack of knowledge of them. Thousands of chemical equilibrium reactions that are very easy to reverse. Okay, and the last one obviously is, well, usually we talk about chemical reactions. So if I just jump over to here, formation of new substances. So it's really, if you go into a bit more detail, it's the breaking and forming of bonds. But dissolving is here ionic breaking of ionic bonds. So that is breaking the chemical bonds, and it is forming new bonds with intermolecular forces with the water. So that really is a chemical change. So the reversing of that. So the whole issue of dissolving being a physical change, when there are chemical changes going on, as far as forming a new substance, it just makes all the terminology just some sort of smoke screen. And it'd be great if we just deleted that terminology altogether, because it is just hiding behind words. What we should be looking at is the positive and negative attraction between the different particles in all of those chemical and physical reactions, because that will give you a true understanding of what's going on and why. Forget whether you want to label it as a physical or a chemical change. Instead, look at the positive and negative attraction between the forces, not even ionic, covalent, and metallic bonding, all the main types of intermolecular forces, but what are the strengths of the positives and negatives that are causing it to be in whatever physical state or dissolving or chemical reaction. That is the true understanding of chemistry. That is particle theory, positive attracted to negative. So it's a bit of a smoke screen, this whole physical chemical changes, full of issues, and covers up a proper understanding of how particles interact, which is the strength of their positive and negative attractions.